Can you see my screen?
Yes.
Okay, thank you. Good afternoon, everyone. My name is Emorfia Constantinide, and I am an agriculture inspector in the Department of Environment of Cyprus. And my presentation today will mainly focus on the new legal framework that was introduced by the European Commission and the challenges that we have to confront with. As we all know, the aim of the Real Life Waste project was to support sustainable green growth in the Mediterranean area by encouraging the use of innovative technologies by both public organizations and private companies for a more efficient management of waste generated by livestock facilities. Now, the main outcome of the project was the transformation of livestock waste into organic, high-value commercial fertilizer known as struvite from the project 4 pilot plants. Now, to have a better look in the problem and the environmental impacts of livestock sector, you can see that the development of intensive livestock farming across the European Union is leading to environmental problems such as water and air pollution, and is contributing to climate change. Moreover, the concentration of a large number of animals indoors or in confined spaces, where animals are fed mainly on commercial feed, leads to waste and animal byproducts generation, both liquid and solid. Livestock and agricultural activities cause, among other things, emissions of ammonia, which contribute to the soil acidification process, the eutrophication of water bodies, and the pollution of the lower atmosphere with ozone, together with other pollutants. Now, more specifically in Cyprus, the main environmental problems associated with the improper operating and waste management are primarily related to large volumes of slurry, as you can see in the diagram in the picture, high concentration of nitrates and high salinity, which causes problems in the use of slurry as a fertilizer, emissions and other air pollutants, particularly ammonia and other volatile organic compounds, and also pollution of surface and groundwater, primarily due to the waste runoffs from the storage areas. Now, the legal framework that we have to deal with now is the new regulation 2019-1009 on fertilizers. So far, the European Union's fertilizer policy has been exclusively on mineral or chemically produced fertilizers. On June 5th, 2019, the European Parliament and the Council adopted the new regulation as it called 2019-1009, establishing rules on the availability of EU fertilizing products on the market. Now, this regulation, for the first time, refers to materials such as struvite, biochar, and ash-based products, and states that there is a market demand for the use of such recovered waste as fertilizing products. The Parliament and the Council have authorized the Commission to issue amendments to the regulation of the above products in the EU's fertilizer components. Now, this project, our project, Real Life Waste, has provided several solutions. Some of the solutions are the production of a valuable fertilizer known as struvite from one existing small-scale pilot plant in Cyprus, which was upgraded, and 3 other small-scale pilot plants in Bosnia and Herzegovina, Spain, and Italy, which offered innovative instruments to livestock SMEs involved in the project in order to improve their innovation capacities and opportunities to transform waste from an economic and environmental problem to a valuable resource in the form of an organic, commercial, and eco-friendly fertilizer. Furthermore, it provided solutions for the reduction of environmental impacts in air, soil, and groundwater, and also the livestock facilities and farmers can produce, use, and sell struvite. The amendment now of 2019 gave some new restrictions that they are proposed in the document, and more specifically, the scientific members of the European Committee examined the possibility of struvite to be included in the list of biofertilizers. During the meeting that took place in November 2020, the scientific committee completed their evaluation on struvias and decided the requirements that struvite needs to meet in terms of composition, the allowable waste that this material can be recovered from waste so that it meets the quality criteria set, based on a 460 pages document prepared by the Joint Research Center. In the two tables below in the slide, you can see some of the proposed restrictions. Now, what are the challenges that we need to face and work further? Limitations due to the minimum phosphorus content and due to the maximum organic carbon content of 3% of the dry matter content. Moreover, economic impact of meeting the limits of the proposed amendment. Some limits constitute a barrier to the use of livestock waste for the production of struvite. There is also a challenge for the needs to further research and also the utilization of available financial tools. As I said earlier, the limitations due to the minimum phosphorus content and due to the maximum organic carbon, the economic impact of meeting the limits of the proposed amendment, and some limits that constitute the barrier. All of the above can tell us at this point from the results that we have from all the pilot plants and their evaluations, that the produced struvite can no longer be considered as a retail market product of acceptable quality. And furthermore, it prevents the possibility of exploiting this material, especially in countries with high population in animals, in relation of available spreading area, with the fact of drifting away from the circular economy. Moreover, the new limitations engages interested parties to make a significant investment in order to produce struvite of high purity and extremely low concentration of organic matter. Moreover, and from the discussion in Cyprus, they have been recognized the following areas for further research. During the pilot study, struvite that was produced from livestock waste was evaluated on 3 types of vegetables in the laboratory, in greenhouse conditions, and on control peat substrate. The need for further research using local soil was pointed out. Also, further study is deemed necessary to assess struvite solubility on various soil types, as well as the likely environmental impacts that may arise as a result of its use as a fertilizer. Moreover, further agronomic studies are required in several species of horticultural, fruit, forest, or ornamental plants to verify the effectiveness of struvite as a fertilizer. Since such products may contain struvite in various contents, further research is also necessary to determine whether the struvite content affects the efficacy of the final product. Furthermore, there is a need for utilization of available financial tools. Promoting the production of struvite in European regulation requires the utilization of all relevant available financial instruments. The main financial instruments are the following: the Sustainable Europe Investment Plan, which focuses on tackling climate change and will mobilize public investment and help to free up private capital through EU, the European Innovation Council, the European Institute of Innovation and Technology, which will coordinate innovation initiatives for the circular economy, the new program Horizon Europe, the action of Marie Curie, the LIFE program, the European Regional Development Fund for the period 2021-2027, the European Social Fund Plus, the European Investment Bank, government subsidy, and also the Common Agricultural Policy. Now, concluding my presentation regarding the regulation, the modification of this regulation prepared by the European Commission answers the questions related to the technical specifications for the production and the quality characteristics of the struvite as a fertilizer component. Moreover, the whole production process gives the farmers an additional benefit to increase their revenues that will enhance their capacity for sustainable production, thus making their businesses both more environmental and economically sustainable. Now, the main future actions required to achieve the goal of promoting the production of struvite in the European regulation are the following 3 steps. Further research regarding the development of struvite production technology and the environmental impact and behavior of struvite in various soil types, and also the effectiveness of struvite in different plant species. Regarding training and awareness of interested parties on the technology, its potential and the benefits of its adoption, and also the characteristics of struvite as a fertilizer, its use and the effectiveness in relation to other commercial fertilizers. And last but not least, the financing part, where we need to figure out how to finance livestock units for the installation and production of struvite, and also to finance farmers for the use of struvite. Thank you very much for your attention.